So today we're going to talk about logarithms, all right? So hopefully all doing well today, students. And we're going to talk about this. So what are logarithms? What are logarithms? So today's goal is I can use and graph logs, or logarithms is what we call them. So what is a logarithm? Well, we have something like this. Let's say we have y is equal to 2 to the power of x. Well, a logarithm is the opposite of, well, that. So if I have something like, if I want to find the inverse, remember we talked about inverses a while ago, or the opposite of that. If I want to find the inverse of that, I switch x and y around, and you don't have to do this when you do this today. And then we resolve for y, but the issue is how do I get rid of a base? How do I get rid of a base? That makes no sense. So they invented this thing called logarithms so that we could get rid of bases. And we'll talk more about that next class. Today we're just going to learn how to use logarithms, and we're going to solve with them later. So the opposite of a log, or the opposite of a base, is a log. Oops. Let me show you here. A log with the same base, that log base 2 and base 2. So these here are inverses, they're opposites, meaning that if I have a log 2 and a base 2 of x, that means these are going to cancel and I'm left with just x. So logs and bases are opposites. We're used to bases like 2 to the third power. We're used to that. 2 to the third power is 8. Right? 2 times 2 is 4 times 2 is 8. So log base 2, and I keep doing LG, so log base 2 of 8, okay? So to read this is what power of 2 gives 8. That's what that means. So we could try it, and we'll talk more about it, but the answer is 3, and I'll show you that here in a minute, okay? So that's what we're going to do. So what power does this need? So what power does 2 need to be 8? That's what that means. So what power does 2 need to be 8? And this is going to equal. This is the same thing like writing 4 plus 2. That equals 6. Log 2 of 8 equals a number, just like that same logic. It is an operation. So you're used to adding, you're used to subtracting, you're used to multiplying, you're used to dividing, and you're used to using bases. And so now you're going to use logs. They are an operation, okay? So let's go 2 to the first power. Well, that's 2. 2 squared, that's 4. 2 to the third, that is 8. So because 2 to the third is 8, this here is the answer here. So notice that this guy and this guy, or girl, if you want to call them girls, are the same thing. Okay? They're the same thing. Notice that. Where the power is the answer, and the log 2 of 8, the of 8, is the answer here. So they're kind of backwards of each other. Again, that's why they're inverses. Okay? So here is a 3, and we want 1/9. Now don't get worried about fractions, because remember, fractions are negative powers. Okay, fractions are negative powers. So don't worry about the fraction. We have a 3 and a 9. How do I get so what power gives me 9? So what power gives 9? I'll probably do an extra example here too after this. What power gives 9? So we have 3 to the first power is 3. 3 to the 0 power is 1. 3 squared is 9. So 2. So this is going to equal negative 2 because it's a fraction. That's all. All right. So let's do another one real quick. So let's do something like log, what's an easy one? Let's do 3 of 81. Okay, so 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9, 3 to the third is 27, and 3 to the fourth is 81. So this number is going to be the answer. Not 81, sorry. Okay? So notice how that works out. You just go through the powers of your, well, it's called log base 3. That's what it's called, base 3. So you just go through your bases of 3 until you get your power that you need, and that's the answer. Now, sometimes there is a blank. So notice there's a mystery, there's a blank there. So this invisible number. So if you look at your calculators, there will be an invisible number there. That invisible number is 10. Okay? So whenever we have an invisible number, it is 10 with logs. So this is actually log base 10 of 10000. So is that right? 1, 2, 3, 4, 1, 2, 3, 4. Yes. So then what power of 10 gives us that number? All right. Then there's also this ln log we'll get to later. Okay. So here we have this. So 10 to the 0 is 1. 10 to the first power is 10. 10 squared is 100. 10 to the third power is 1,000. So 10 to the fourth power is 10,000. So that would mean that this is the power that gives us, that matches. So then the 4 will go here. Okay? Which is fantastic. Now, let's look at this. So we have 5. So what power of 5? So 5, 0 gives me 1. 5 to the 1 gives me 5. 5 squared gives me 25. Wait. That doesn't work. Well, if it doesn't work, we're going to use a calculator. Let's get our calculators out. So here's my calculator, and I'm going to put this in a little weird, okay? It's called change of base, because this log button that I have right here is log 10, not log 5. So what we need to do is we need to do 2 logs, one divided by the other. So I'm going to start with the top number. So the top number is 8. So it'll be 8 log 8 divided by log 5. Okay, so it should make sense. The top number goes on top, the bottom number goes on bottom. I'm going to enter, and I get 1.29. So I got to find where that is at. Sorry. There it is. So again, I put this in the calculator. The top number goes on top, the bottom number goes on bottom, and we get 1.29. So could you do that with all of these? Yes, you could. Okay, so we're going to do this one here. So the number on top is 0.0006 divided by the log of 12. So let's do that. Let's put it in the calculator. So let's do it. So the log of 0.1236 divided by log 12, enter. We get negative 2.95, so I'll do negative 2.99. That's what that's going to equal. Okay? So not too hard. Just put in the calculator. Graphing these. So logarithms and bases are opposites. So if we have a base, it's either going to be growth or decay, right? And so our logarithms are going to have very, very, very similar shapes. They're just going to be rotated a little bit because they're opposites. So the growth, it's going to look exactly the same. It's just going to be shaped a little differently. So here we have growth, here we have decay, and so logarithms are going to do the same thing here. So let me just draw a picture. So if I was a log and these are opposites, they're kind of going to look like a little flipped. So a log is going to look like a growth function, and it's going to look like this. And then the decay function logs, if we have a decay function that looks like a log, it's going to look like that. Okay, so it's the same shapes, just tilted sideways. So if you see that. And so we're going to graph these, and these have very similar steps, but they're kind of backwards. So step 1 is the asymptote. Okay, now this has an asymptote that goes left and right. So this has an asymptote that goes up and down. So see how they're basically opposites, okay? So this right here, this 0 is the asymptote. And it goes up and down. So this would be plus 4. So I'm going to make a graph here. And then 1, 2, 3, 4. At 4, I'm going to have this asymptote that goes up and down. Okay, so that's step 1. And then step 2 is your XY table. And then, so I'm going to just get this all fitting in here. So step 2 is your XY table. And what you're going to do is the same 0. You're going to put it down here, but you're going to add 1 to it. So it'll be 4 plus 1 is 5. And then we will go, we can go 1 up, but it won't, so then the next number is going to be adding this here. So I'm going to take this 4, and we're going to add that whatever's there is our next number. So we're gonna make that 9. So I'm going to add 4. So whatever that number is what I'm going to add there. Because these are interesting numbers. You're going to get some really crazy decimals if you don't do it right. So if you don't want decimals, take that number and just add it, and then the next one would be that squared. So then you would add like 16 and so on and so forth. But you could go 5 and 6 and 7. It would just give you some really interesting decimals. So and that's fine. So but the really key part to this is starting out with that 5. And my pen's out of ink or something here. Let me get a new pen just a second. So I'm going to put these numbers in. I'm going to get numbers out, and I can do that in the calculator with my change of base. So we have log 4 of 5 minus 4 plus 1. And then we can put that in the calculator. I would simplify this down. So 5 minus 4 is 1. And then I'd put in the calculator